All right, so we're going to be talking about the tangent function today. And the tangent function is different than the sine and cosine. Got to bring up my colors here. In both the way it looks and in a lot of its key features. So here's what our parent function looks like. It's y, or f of x, equals tangent of x. If we go back to the same way that we defined the sine and cosine, by looking at our quadrantals, we'll see that we don't quite end up with a good picture just by doing this, because what ends up happening here is when I plug in 0 for x, the tangent at 0 is 0 divided by 1, which is 0. So 0, 0, that seems normal, so we have to plot that. When I move to pi over 2, though, up here, when x is pi over 2, the tangent is 1 over 0, which means it's undefined. This is the first time in this class, certainly not the last, but the first time in this class where we've had to graph something that has an undefined value. And an undefined value puts something called an asymptote into our graph. Anytime you divide by 0, have a 0 in the denominator, it gives us an asymptote. An asymptote is simply a line. It's really kind of an imaginary line, which is why we draw them dashed, because you couldn't actually see it if you graphed it on your graphing calculator. The asymptote wouldn't appear. But what an asymptote is a line that a graph approaches but never reaches. So we put in an asymptote at pi over 2. As we move on then to over here to pi, 0 divided by -1 is 0. So I'm back here. So I did a point on the axis, an asymptote, a point on the axis. Now, if I go somewhere else, then I'm not done. So I would look at where I went next. If I were to move to 3 pi over 2, -1 divided by 0 would also be undefined. So we notice we've already started repeating the cycle. So this is why tangent only has 2 marks on each side, because it starts repeating earlier. So it starts repeating after pi instead of after 2 pi. On the other side, if we move in the negative direction and go this way, if we do the tangent of negative pi over 2, that's also undefined because I land right here. So at negative pi over 2, because it's undefined, that means I have another asymptote right there. And then as I move to negative pi, then it'd be at 0 again. So the first pattern that you have to know for a tangent graph is we're going to call these points inflection points. That means a point where a graph changes direction. So inflection point, asymptote, inflection point is the first pattern that you have to know. Now, this certainly does not define a graph. I need some other stuff. So what I need to do is I need to look at the tangent value kind of somewhere between 0 and pi over 2. So I'm going to look at pi over 4, or 45 degrees, because I know that the coordinate there is radical 2 over 2 on both the x and y, which makes it easy to calculate my tangent, because sine divided by cosine, the sine and cosine are the same. So when we divide them, it's 1. So that means that halfway between 0 and pi over 2, I have a value of 1. If I look at the value between pi over 2 and pi, and again, I look at the 45-degree angle because it's the one that's easiest to calculate tangent for, my cosine is negative over here and my sine is positive. So when I divide these two, I get -1, whereas here I got +1. So that means halfway between pi over 2 and pi, I have a value to plot on my graph at -1. If I were to go to the negative direction, over here, I have a positive x but a negative y, so that means I'm going to get -1 again. Over here, they're both negative, which means I'm going to get +1. So that means it's negative here, because that's between 0 and -π/2. And then over here, between -π/2 and -π, it's at +1. And so here's the other pattern that you have to know. After you plot the pattern, inflection point, asymptote, inflection point, then I draw it like this because it's between those two, halfway between specifically. I write up, branch. Sorry, I can't really fit the word branch in there. And then I write down, branch, because that's what it's going to look like. Between 0 and π/2, I'm drawing an upward moving branch. Between π/2 and π, I'm drawing a downward moving branch. This, on the other side, this was an up branch, so that means the next one is a down branch. This one was a down branch, which means the next one is an up branch. And this is our parent function. So you have to know two patterns. You have to plot inflection point, asymptote, inflection point, asymptote, inflection point, asymptote, so on and so forth. And then you have to put in up branch, down branch, up branch, down branch, up branch, down branch. Now, you don't just draw the branches without plotting the points like we did here. So make sure you do that when you graph yourself as well. The period of a tangent graph is pi instead of 2π, because from here to here is all we have before it starts repeating, because the next thing I would have would be another up branch and an asymptote. So the period is pi, which is why I only have 2 marks instead of 4. Asymptotes, we write the location of the asymptotes the same way we wrote the locations of the max and mins on sine and cosine. I have my first asymptote at π/2, and we write x equals because it's a vertical line. So we use the same pattern as with sine and cosine. We list where the first one is, so π/2, and then we put plus whatever the period is, in this case pi, times k. It's always plus period times k. First location plus period times k. Now on the zeros we also list as x equals because remember they represent solutions. The first one is at 0 plus period times k. Now this time I need to simplify because 0 plus something is just itself. So final answer on the zeros is just x equals pi k. Because of these asymptotes, my domain is very strange, but it also follows a pattern. So we've got lots of patterns to remember on the tangent graph. Domain describes what x is allowed to be. And x is allowed to be anything except where I would be dividing by 0 or where the asymptotes are. So the way that we write that is we write all real numbers. The symbol for all real numbers is an R with an extra line on it. So that's what that means, is all real numbers, except, and then you just write out where the asymptotes were located. So we already did that. They're at π/2 plus pi k. The range. Lowest point on the graph, I can't find one because I've got arrows going down. So that means I start with -infinity because we look down. Then I look up and I see I've got arrows going up as well. So tangent range is -infinity to infinity, and its domain is special and restricted. Our standard equation for tangent looks much like it did for sine and cosine. You've got the a multiplied in front, the b multiplied times the x. Now, write this down. A is not an amplitude for tangent graphs. Because remember that the definition of amplitude is half the height of the function. Tangent graphs don't have a height because they go on to infinity. So there are no amplitudes on tangent graphs. If you're asked for the amplitude on a tangent graph, you should write none. Now, that doesn't mean that A isn't important. A is definitely important. We're still going to use it when we graph it because it still represents vertical stretch when A is greater than 1, or shrink when A is between 0 and 1. Now, your B is still going to help define the period, but notice that the formula's changed. Here now, the period is going to be pi over B instead of 2 pi over B. So we're going to use those things to help us graph and then also to write equations, just like we did with sine and cosine. So here's my equation, 2 times the tangent of pi x. So the first thing I'm going to do is find the period. Again, the formula is pi divided by b. So I do pi divided by, the b is what's multiplied times the x. In this case, it's actually pi. Well, pi divided by pi is just 1. So the period of my tangent function is 1, which means that's what I label my second mark. Because again, if we look at the parent, it's the second mark where we hit a full cycle. So that's 1, which means this has to be a half, -1, -1/2. So I look at my two patterns. My first pattern is inflection point, asymptote, inflection point. So I use that. Inflection point, asymptote, inflection point. And same thing on the other side. This is an inflection point, so this is an asymptote, and this is an inflection point. Now, here's where A comes into play, because when I go to use my second pattern, which is up branch, down branch, up branch, down branch, I need to know how far up and down to go, and that is my A value. So this is a vertical stretch, which means it's going to go up further, faster. So that means I'm going to label my y-axis going up to 2. And then those are going to be my halfway points. I know my first one's going to be an up branch, and the halfway point should now be at 2. So up branch. This one's going to be a down branch. So at the halfway point to that asymptote, I go to -2. And then I repeat the pattern on the other side. I know that this next one should be a down branch. So at the halfway point, I go to -2 and draw my branch. And then this halfway point should be an up branch. So I draw that. So I've got my graph done. I've identified the period. I also need to identify the zeros and the asymptotes. So same pattern. First plus period times k. So x equals first plus period times k. 0 plus 1k is just k. So it's x equals k is where my zeros are. My asymptotes, same pattern. X equals the first one, which is 1/2, plus the period, which is 1, times k. Again, I don't write 1k in a final answer. So x equals 1/2 plus k. And that's all we wanted. B, same idea. First thing I'm going to do is calculate the period using this formula here. So pi divided by b. B here is 2/3 because that's what's multiplied times the x. So we've done plenty of dividing by fractions. That means to multiply by the reciprocal. So pi is understood to have a denominator of 1 since it didn't have 1. So that's 3 pi on the top, 2 on the bottom. So my period is 3 pi over 2. So that's what I label my second marks. The first marks have to be half of that. So 3 over 2 times 1/2 is 3 over 4. So this should be 3 pi over 4, -3 pi over 4. So now I start my pattern. Inflection point, asymptote, inflection point. Asymptote here, inflection point here. Now I look at my A value. A is 1/3, so that means at the halfway points when I go to do my branches, I should only be going 1/3 of the way to 1. So halfway point to the asymptote, 1/3, up branch. Halfway point to the asymptote, -1/3, down branch. And then continue on the other side. Halfway to the asymptote, down branch. Halfway to the asymptote, up branch. Zeros. First one is at 0 plus 3 pi over 2 times k. So that's just 3 pi over 2 times k, because 0 plus we don't need to write. Our asymptotes, the first one is at 3 pi over 4, so x equals 3 pi over 4, and then again, the pattern is the same every single time, plus period times k. And there we have it. We're done with our graphs. Now, the graphs are more difficult on tangent than they are for sine and cosine. The example 2 part is not more difficult at all. It's the exact same, because all I need to write the equation is the value of A and the value of B. So vertical stretch, that's telling me that A is 3. So I know A is 3. So now I just need to solve for B. Again, make sure you're using the new formula for tangent and not the one for sine and cosine. So I'm going to say pi over B equals the period, which is 4 pi. So to solve for B, I can switch the location of B in the 4 pi. So I know B equals pi divided by 4 pi. The pi's cancel out then, which means B is 1/4. So when I go to write my function, f of x or y equals A, which is 3, times tangent of B times x. 1/4 times x is x over 4. So 3 tangent of x over 4. Last one. A value here is my vertical shrink, which is 2/9. To find B, I need to set B equal to the period. So pi over B equals 5 pi over 4. Again, I personally think it's easiest to solve this as a proportion by cross multiplying, but certainly you can make your choice there. So multiply these together and set it equal to these two multiplied together. So here I've got B times 5 pi. I set that equal to pi times 4, which is 4 pi. To get B alone then, I would need to divide both sides by 5 pi. So pi's cancel, these cancel. I've got B equals 4/5. Yay, I've got A, I've got B. I can write my final answer. So f of x or y equals 2/9 tangent 4/5 times x would be 4x over 5. All right, so again, big ideas. Make sure you know that tangent does not have an amplitude, that you know the formula is pi over b, and that you know all the patterns. So the patterns for graphing, inflection point, asymptote, inflection point, followed by up branch, down branch. And then that you also know the pattern to get the asymptote in zeros, which again is location of the first one plus period times k. All right, that is it for tangent. Your homework is your worksheet.